Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled an optimized hybrid filter designing for speckle noise reduction in ultrasound images. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed in order to remove the noise or the effect on the images, especially for the medical images. So where we have used the optimization algorithm. So let's see what exactly we have done. Before moving to the video, let's talk about that what we will cover into it. We will initially talk about the application areas where the developed system can be used, followed by the code that we have designed, how to execute it, what files you need to required, and the software requirements for it. Then we will talk about the current systems, those are working in the same domain, and the problems identified in them, and what exactly we have developed for that. Finally, the experimental outcome and finding will be discussed. So as I already told, the project is related to the noise removal from the images, especially for the medical images. So it is not restricted only to the medical, but can be used in many of the areas like forensic, for the satellite remote sensing, photography, and medical images, where when the ultrasound images or some device related noise get affected on it, and in order to remove that, there is a requirement for the filtration so that the required information can be extracted out. So now let's see the code. So the folder that we are going to provide you will be like this, under which there is a code folder in which we placed all the files. The whole code is written in the MATLAB, so in order to run the code you must have the MATLAB software with you. The MATLAB version that I am demonstrating here is 2015B. So in order to run the code, just go to the folder, copy the path, and then go to the MATLAB, paste it here, and press enter. And then out of all the files, you just need to run the main code. This is the main code in which you can process the data. So secondly, there is a comparison folder which I will show you later, where we have saved the results and comparison can be done. So in order to run this code, whatever the file you have opened, you just need to click on the run button. You need to select any of the file. Let's say I'm selecting the Lena test and press open. So before running that, I'm reducing the iterations because it will take so much time in order to complete the simulation. So I'm just entering 2 here, so rerunning it. So I just selecting any of the file. You can select the medical file or any of the other images. So we have put the medical images as well as the normal images, because for the normal images we want to compare it with the existing system in order to show the results. So I'm clicking on the open. So you can see it will ask me for the 2 types of the noise. One is speckle, which is basically in the medical images caused due to the medical equipment. Second is Gaussian, which is basically the environmental noise. So here I'm entering the first type of the noise and press enter. As you can see, it will start processing and reduce the noise with variability, and will try to give the better results. So in the meantime it is running. Let's talk about what exactly we have done. We were following this paper in which they have developed the system Speckle Noise Reduction using the winner filtering and adaptive wavelet thresholding. So they were using the thresholding method, where the thresholding is given by the user, and winner filtering. So winner filtering is good because it is considered to be the good for the speckle noise, but adaptive wavelet thresholding is basically inspired from the method where the iterative methods has been implemented in order to get the threshold, and on the basis of the threshold the noise is being reduced. But what we have identified, these methods are successful up to an extent when when the images will be varying. Here they have tested it on the normal images, but we were developing for the medical images where the challenge is more. So what we have decided, in order to remove this thresholding concept, we have implementing a digital filter implementation, which will take any of the input as a signal and helps in reducing the noise. So in the digital filter, we are applying the Butterworth filter, to which we are tuning by using the firefly optimization algorithm. So Butterworth is a digital filter. So might be you people are aware that the digital filter process, here you can see the optimization algorithm we are using, firefly optimization algorithm. It is a bio-inspired meta-heuristic optimization algorithm, so it is proven to be the best with among the other existing method like PSO, GA and many more. So inspired from that, we have choose that. And the digital filter is basically having few parameters that we need to adjust in order to get the better results. So digital filtration, the Butterworth filter we have used, so tuned it by using the firefly optimization. So here you can see it is still working. In the meantime it is completing. Let's have a look to the code. So in the code, what we have done, I'm just minimizing it will be open again and again. Let me minimize it. Let's wait for it to get finished. Mm. In the code you can see we have initially selected the images, then converted it to the grayscale, and then applied the noise as per the user input. And then one of the case where we are doing the hybridization of the proposed method. So here you can see the results are there for the PSNR. So let's see. So for the filtration process, one, we have applied the Butterworth filtration. Secondly, we have applied hybridized it with the winner filter. So one of the case was there when only winner filter and the Butterworth filter is applied with the static coefficients. So the coefficients here are initial cutoff lower and initial cutoff upper. Later on, in order to decide these two factors, I have applied the firefly optimization algorithm, for which the fitness function is defined to be, so here you can see the fitness function, where every time whatever the factors we are giving, whatever the outcomes came, we do calculate the PSNR. And on that we are checking that how much exactly the difference were among the two when the final images and the actual image variation, noisy image and the actual image variation is there. So we are calculating the PSNR for the noisy and original and filtered and original. So when the difference among them will be increased, then it is considered to be the best. So the firefly give us the best position, and we are converting it to the decimal and then putting these factors in place of new cut lower value and upper value, and on that we are getting the final image, to which we are passing to calculate the PSNR other factor. So compare fitness function, here you can see under this we are calculating the factors and giving us the fitness and the PSNR and returning it to the main function. So these factors we are running, and you can see here the results for the fitness and the PSNR value. So as the base paper we were using, they have tested it on multiple images like Lena, a Pentagon, cameraman, Egypt, monarch and house. So we have considered the same images and saved the results. Here you can see I have saved by using this command. So put it in an individual folder. So here we have saved the results in the different mat files. This is for cameraman, house, Lena and monarch, and you just need to run this main compare file where these files are directly loaded, and a comparison can be done under the different factors. So when I'm running this code, you can see just wait a minute, might be I just commented something. So I'm running it, so you can see the proposed results are here. These are the proposed results. Rest results for the Leo or the traditional, we have taken the results from the base paper because they have given for the Leo as well as their own results. So while comparing, we came to know that our proposed methodology is showing better results in terms of different factors. So let's have a look at what exactly we have demonstrated. So this was the PSNR values of the 4 images from the proposed method. This is the fitness value achieved for the different images. This is the SSIM, similarity index, and then when compared with the previous methods, the PSNR value of the proposed method is higher in comparison to the traditional and the Liu method. Even similarly, SSIM is higher, which proves the proposed method is proving better in order to reduce the noise and giving us the more refined images. So you can work with the same. or specifically medical images, because we have used the digital filter which does not depend upon any of the normal images or any other factors. So here I'm selecting the medical images. Here this is one of the image. I'm just selecting it, so you can see it will ask me for the noise. So I'm putting the speckle noise and it will start refining it. So in the initial you can see this is the noisy image, and this is the iterative results that we are getting every time in order to improve the outcomes. So it will process the same procedure as it was before, so I'm just quitting it for now. So further modification are still possible into it. We can design more complex and more effective filtration in the domain of the medical or the normal images in order to get the better results. So I hope you people like this video. For more details, stay connected and you can contact us directly. Thank you. Thanks for watching.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.